Hello, 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 ladies and gentlemen, and welcome back. Welcome back to the 2007 Euclid Math Contest. And we are on question number 5 here. So we've got a light bulb and a written part here. So let's take a look at the light bulb question. In the diagram, a sector of a circle with center O, it's down here, and radius 5 is shown. What is the perimeter of the sector? And so the only real notable thing here is that the angle of this sector is 72 degrees. And we want the perimeter. Okay. Well, I can see that my perimeter is going to be OA plus OB, these two radii, plus whatever the arc from A to B is. And that's the challenge for this question, is finding out the arc from A to B. Okay. Now, a sector is very much like a pie slice for a circle. And so the angle of our slice, the angle of our sector, is going to determine everything. If we wanted the area, all you really need to know is the radius and that angle. If we want to know the length from A to B, the arc length there, all you need to know is the radius and the angle there. Because it's if you sort of think back to probably when you learned about fractions, I know when I learned about fractions, it was pies and pizza. These are nice round things. And, you had a quarter of the pie or a third of the pizza and that sort of thing. So that's how we learned about fractions when I was growing up. And the logic still applies for these sectors of the circle. They are a portion of the bigger circle. And that's what we need to realize in order to get a formula for this arc length A to B. Because A to B is just a fraction of the total perimeter or circumference of the circle. And we can sort of complete our circle here. If we draw the full circle, we know its radius is 5. And we know how to get the circumference of a circle. The circumference is 2 pi r, or pi times the diameter. But they give us the radius, so we use the radius formula. Okay? But we just want the section from, say, A to B. How can we figure that out? Well, the angle here is 72 degrees. And what's the angle of a full circle all the way around? 360 degrees. So as I say, this slice here is a fraction of the total. And we can get this arc length AB is a fraction of the circumference. What fraction is it? You take the angle that you've got, 72 degrees, divide it by the total angle that's there. We multiply it by 2 pi r. And now 72 out of 360, that's 1/5. And 2 pi, in this case r is 5. Wouldn't you know it, we're going to get 2 pi. So that's going to be our arc length AB. And now we can answer the question that they asked, the perimeter. Is OA plus OB plus that arc length AB. So that's going to be 5 plus 5 plus 2 pi. Final answer here, 10 plus 2 pi. Okay, now it's a light bulb question, so if you can do some of that in your head, you don't have to draw pictures or anything like that, that's fine. As long as you're confident in your answer, go with it. It'll save you time. But if you're not so confident, you think, well, I'm not sure I got this fraction here right because I have trouble reasoning with these sorts of things, you want to show your work. That way maybe you can get 2 out of 3. Okay, so that's A part, our light bulb. Now let's get on to the B part down here. In the diagram, A is at 0A, so it's on the y-axis. Lies on the y-axis above D, which they're telling us here is 0, 1. If the triangles AOB, so this right angle triangle here, and BCD, that triangle there, have the same area, determine the value of A. Explain how you got your answer. All right, what can we do here? Well, we have all the coordinates for B, C, and D. So in theory, I should be able to get this area here. And then I have a base of 1 and a height of A. So I should be able to figure out A from there. The only question is, okay, how can I use these coordinates here to figure out the area of B, C, D? And I'm sure there is a formula for the area just in terms of the coordinates. Can't think of it off the top of my head. I imagine if I were to use vectors, I'd be all set, but I try and shy away from vectors because depending on where you are, vectors are not something that's so familiar to you. I remember what I did when I was in high school around the time these contests were written. Vectors was in a grade 12 course, but there's always a non-vector way to do these sorts of things. Vectors was never required for the Euclid, so I try and shy away from answers that, while may be obvious to me and would still get full marks if I used vectors, if they use vectors, I try and just avoid it and try and find a better way to do it. So, what can I do? Well, let me think on that while I copy this picture. We're going to need another page here. So we got A up here. AOB. And then D is about here, and C is up here. Alright, now D was at 0, 1. B was at 1, 0. C up here was something like 2, 3. I'm going to say it was 3, 2. Let's just double check. Yeah, it was 3, 2. Okay. And then A is somewhere up there. But the point of it being bigger than D, A is going to be a positive value, so we don't have to worry too much here. Okay, so first things first, I want to get area BCD. How can I do that? Well, there's not... I'm trying to find the best way to do it, because I don't think there's a really easy way to do it. I think if I drop this line here, I will, and call this, I don't know, E. ODCE is a trapezoid. I can get its area. I can get the area of BCE because it's right angled. And I know the height, and I can get the area of BOD because it's right angled. It's question 6, so I don't want to really look for a particularly elegant way to do it. So I'm going to say, let E be at 3, 0. So ODEC is a trapezoid with height, this distance here, which is 3, 0. For a trapezoid, we care about the parallel sides. So these sides are parallel. They're both they're parallel to the y-axis. So this is our bottom and our top. So the height is the distance OE3. The top has a height of 1 here. And the bottom is CE, which is 2. Okay, so the area of ODEC is 1/2 height times the top plus the bottom. This is going to be 9/2. So area of AOB is the area of BCD, which is the area of ODEC, minus these two sections here, these two triangles, minus the area of BOD, minus the area of BCE. So this is going to be 9 over 2, which we just worked out. And then we have a distance of 1 here, a distance of 2 here. So minus 1 times 1 over 2. It's a height of 1 here. Minus 2 times 2 over 2 here. So that'll be 9 halves minus 1 half is 8 halves. Or better known as 4. And 2 times 2 over 2 is 2. So this is 4 minus 2 is equal to 2. So the area of AOB is equal to 2. Okay, well I know the base is OB, which is 1. So 2 is 1 half OB times OA. So that's 1 half 1 times A. If you wanted to, if you were uncomfortable, you might make a note A is positive, as capital A is above D. They gave us that in the question. So we've got 2 is equal to 1 half A. A is going to be equal to 4, and I think that's all they asked for, is just what is A. Yep, explain how you got your answer. I took them on quite a little journey. We created a brand new point E just because we needed some way to get the area of BCD. Once we had BCD, that's the same as AOB, and then we could get little a. So how do we get BCD? Well, you could probably explain your vector technique if you had one. There's probably a couple other ways we could chop just this picture up into smaller, more familiar, more easy to calculate areas. I chose a trapezoid. You could certainly have done something else, I'm sure. But the trapezoid worked, and then I just subtracted off those smaller triangles. And from there, it was very quick to get A. As it should be. It's question 6. Shouldn't be taking us that long. No, it's not question 6. What am I talking about? It's question 5, isn't it? Well, now I'm curious. Yeah, it's question 5. I don't know why I'm saying question 6. I guess I'm getting ahead of myself. Question 6 will be coming up in the next video. But there we go. We've done question 5. And we are now halfway done the whole contest. So, I will see you guys for question number 6. Not question number 5. This was question number 5. I'll see you for question 6 in the next video. If you haven't already, just while I'm thinking about it, feel free to download a copy of the contest and try question 6, 7, 8, 9, 10, the remainder of the paper if you haven't already done so. It's great to practice, and it's probably better for you to practice the questions before seeing me go through them. So, if you haven't already, feel free to go through it. We still have half a paper to go. I will see you guys in the next video.